Hi, in this video, we are going to go through the topic of straight lines in your AA or AISL syllabus 2.1. This is the core syllabus content, so whether you are on the AA stream or AI stream, regardless standard level or higher level, you are going to get the same materials and you are going to be tested the same unless, they give further guidance. Now we are going to start with gradient, the concept of gradient. So what is gradient? To define gradient, we can say that gradient is a number that tells about the steepness. So let me write it here. So is a number that tells you about steepness. In order to get this into understanding, we can imagine a treadmill. You know that basically if the treadmill is not being used, you may see that the treadmill is flat. There is a standing, you can stand on top of it, right? This is flat. And when the incline, you give the inclination towards it, maybe this is a machine and you are walking like this. So the treadmill is going that way and you are inclining, right? So that creates a steepness initially from flat and then, it's going to be increasing. And of course, the higher the inclination, the higher the steepness. So we use that in order to understand a gradient. So if I have a Cartesian plane, so let's make it here. This is the x axis, and we are going to make the y the y-axis, right? Let's say we have two lines. I am going to tell this is the blue line and this is the red line. So you imagine you are walking from the left to the right. So you are standing here. So the blue line is steep, and of course, the red line is steeper. Like, in fact, you feel like you need to climb rather than just walking using your feet, right? So that's how we describe it. To understand the steepness, the comparison, we use the number. Well, how to do that? So we can use 2 points from any line. So let's say we take this point. I will mark it here as a coordinate 2 or point 2. And then here, let's say as the point 1. And then we calculate the difference of the y-axis and the x-axis. So let's erase the line blue here for clarity. So this is the change of y, and here, earlier, is the change of x. So the formula of the gradient, we can call it, or the symbol is m, is the change of y and the change of x over the change of x. And we say it is the coordinate of y2 minus the y coordinate of 1, and then over coordinate of x2, and then subtracted by x1. So we need to get the x2 comma y2, the coordinate of point 2, and we need to also have the coordinate of point 1. And then we can input the y numbers on the top, collect the difference, and also the x coordinate difference on the bottom. We need to be consistent. So we need to start with always point 2 first, subtracted by point 1, and then, point 2 subtracted by point 1. If you start with point 1, then you need to be consistent down here, over here. But to be safe, always start with point 2 minus point 1. All right. So if the number is larger, the m is larger, let's say the m is 5, and then we have another m is 3. So the m5 here is steeper than the m3. So let's say in here is the one that has m equals 3. In here, they have m equals 5. So of course, this is steeper than the blue line earlier, right? That's the idea of gradient. Okay, so as we already know the formula of gradient, we want to understand more in order to be able to compare. So first, you can see that in here, if you put yourself standing here, you walk to the right, you need to go up right? So this, we call it a positive gradient. I will write here. So if m is positive, then this implies that you are walking upwards, or it's going upwards from left to right, like here, left to right, and then it's going up. So this will, when you calculate here, you'll get a positive value of gradient. But let's say if I create here using a yellow color, let's say I cross it here. Okay. This is the red one earlier. But then, if let's say you stand here, you go from left to right, right? And then you go down. Oh, so this is going downwards. And in the mathematics, you will get a negative gradient. So this will cause you walking downwards from left to right. And let's mark it over here for the example in the graph. Okay, but if you take a look, things like smooth here, like on the x-axis, right? You're just walking straight, like, a fine walking in the treadmill without changing the inclination, then this will result in your gradient equals to 0. So this is just a horizontal line. And of course, your equation will be y equals some number. And in x-axis, it is, y equals to 0. Because at any point of x, let's say this is -5, the coordinate of y is 0. At here, the coordinate of y is 0. And at here, the coordinate of y is 0. So x-axis is y equals to 0. And then at another point, the gradient can also be undefined. Okay. When are the cases that this could happen? Well, basically, you know that here is a 0 gradient. Of course, when you start increasing the inclination, it's going to get more and more positive. And then from the flat gradient, if you are starting to decline, you are going to get a negative gradient. So the undefined gradient happens when it is a vertical line. Why is it like that? So let's say I have here this line and I take two coordinates. This is 5.5 and this is 5.2, 5,2. You can take a look that the delta y is y minus 2, sorry, 5 minus 2. But then the x coordinate is 5 minus 5. And then this results in 3 over 0. And, for any number divided by 0, we call it undefined. It is not, we are not able to define it. So the gradient is undefined when you have a vertical line. And this happens, x equals to a coefficient. So for example, like the one we have earlier here, 5, 5, and 5,2, right? This can be resembled with the x equation, x equals 5, because you can see the x remains 5, whatever the y is. Yeah, so we learn how to write the equation for the horizontal and vertical line, and as well to understand the gradient. If it's positive, it's going upwards. If it's negative, it's going downwards. And if we want to know which one is steeper than who, then we just need to see the numerical value, which one is bigger. Okay, now let me continue with the guidance of here. Basic calculation of gradient, and we learn how to interpret it as well as what we did just now. Okay, so now we need to calculate the gradient of AB. So it is this point B and this is point A. All right, it's a good practice to just annotate the point on the screen or on the sketch that we have. So B coordinate is 3, 8. A coordinate is 1, 2. Okay, so now in order to calculate that, so the gradient from A to B, okay, so we can just decide who become 0.1 and who become 0.2. Let's just choose this become 0.2 and this become 0.1. First, take care of the y coordinate, y2 minus y1. So 8 minus 2. So we write here. And then we subtract the x coordinate. We start with x2 minus x1. So 3 minus 1. So we will get 6 over 2, which is 3. So we got it, the gradient of AB, MAB of these 2 points. If they create a straight line, the gradient or the inclination is 3, positive 3. Now we shall calculate for BC. Okay, we haven't write the interpretation. Pardon. The interpretation is that here. So the gradient is moving upwards, right? And then I will write it here. And then if we take a look again at the definition, right? Gradient is delta y over delta x. Okay, so now this implies that, take a look, when you move 2 steps to the right, you go 1, 2, 3, 4, 5, 6. You go 6 upwards. But then in gradient, you are going to use it in the language of 1 step of the x movement. So in here, 3 resembles 3 over 1. So you can see here that every 1 step to the right is 3 steps increasing. Every 1 step to the right is 3 steps increasing. So this is 3 over 1. So we need to explain it that way. So every 1 step of x to the right, or we can say to the positive direction, increases 3 step or value y upwards. All right, so that's for AB. Okay, now I'm going to erase everything so then we can continue with the other points. So next is MBC, this BC. Okay, BC, so we have the point B, and let's just take here as point C. So point C here earlier is 9, comma 2. Okay, so we can calculate it with the same formula. So the gradient of BC. So let me choose this as point 2 again, and here as the point 1. So 8 minus 2, because y2 minus y1. So 8 minus 2 over x2 minus x1, which is 3 minus 9. So we get here, this is 6 over minus 6, which is, this is minus 1. All right. And you can see here, this is declining, right? So that's why you are getting a negative gradient, which is minus 1. And the interpretation that we can give here is that every 1 step of x to the right will result in 1 step of y downwards. You can take a look here. Minus 1 is basically minus 1 over 1. So this resembles, 1 axis to the right. This resembles minus 1 downwards. 1, 1 downward, 1, 1 downward, 1 right, 1 downward, 1 right, 1 downward, so on and so on to reach the point. Yeah, so that's the interpretation of gradient. And if you want to get the more exact language, maybe for exam, then you should say that every increase of x value by 1 unit, right? Because 3 to 4 is increased by 1 unit, increased by 1 unit. So every increase of x by 1 unit will result in minus 1 of y. You can say it that way, or you can say it this way again, 1 unit of y downwards. Because this is a good practice, especially for AI students, because you are going to be asked to interpret this in the gradient. Because sometimes the question is not about, x and y axis. It can be, let's say, time and then price, or distance and price if you're calculating about taxi fare, and you need to interpret what does the gradient mean. Now let's continue with the other parts, which is CD. So I'll keep the coordinate C and erase the B. And let's calculate it here. D is 9, 8. Okay, we can see it here, 9. And then the Y is 8. And here we see the same x coordinate. So this is vertical line. So we need to say that the gradient is undefined, right? So MCD is undefined because it is a vertical line. Well, we can see here that the x is the same at 9. Okay, well, and yeah, the interpretation is already here happening. It's a vertical line. Yeah. So now we can continue with the last part, which is BD. So I keep the coordinate B, erase the C, and erase everything else. So coordinate B here, it's going to be 3, 8. All right, 3, 8. Now let's just do the formula again and see first what's happening here. This is a horizontal line, and we can see the y coordinate is the same as 8, right? So we say here that the gradient of BD will be 0. If you want to see how it plays out, we can calculate, 0.2 minus 0.1. So y2 is 8, y1 is 8, and then x2 is 9, and x1 is 3. 0 over 6 is 0 here. So this is if you want to see from formula, but visually we understand that this is a horizontal line. So the gradient is 0 because it is, so the interpretation is a horizontal line. And the equation is y equals at 8, because we can make a straight line at here. And you can see that wherever we put the coordinate, let's say this is 5, right? It will be 5, 8. So that's why we call it, y equals 8 over here. All right, now we can continue on into finding the missing coordinate. Earlier, we have been doing to, let's say, get the gradient, right? Sometimes in mathematics, we do things in reverse. Let's say we have the gradient, but then we have a missing part of the coordinate. So in this case, let's, go through this question and do it together. I'm also going to show you how to use the calculator on Ti-84 and Ti-Nspire. So the line joining coordinate 2, 7 and k, 3 has a gradient of -2. Find the value of k. Okay, of course, we can go directly into the formula, but because we have, learned how to visualize it, I'm going to show you how to sketch it so then you get a clear understanding. So in here, we can draw any random point at this point here. Let's say P 2, 7. Because we know the gradient is -2, right? Negative means going downwards. So we can just draw the point Q, going right and then going down. So I will locate the coordinate Q here, which is k, 3, right? So now we know that the gradient is -2. So we can calculate the formula. So gradient is, we can say it is coordinate of y2. I will choose the q as the y2. yq minus yp over xq minus xp. This resembles coordinate 2. This resembles coordinate 1. So the gradient earlier was -2, so we can just substitute there. And then the yq was 3, YP was 7, XQ was K, and then XP was 2. So now we just need to cross multiply them. So we will get minus 2, K minus 2 equals to minus 4. And we divide by minus 2. So I write here, divide minus 2, divide by minus 2. And I will continue that up here. So K minus 2 equals to 2. So K is equals to 4. So we got the value of K and underline them twice. So here the value will be 4. Okay, in order to get this from visual understanding, we can also do the definition of gradient, right? So gradient is minus 2. So this implies that every one step to the right is minus 2 downwards. So we kind of like do it slowly with that. So every one step of x and then going 2 of the y. So this is going to be one step of x is 3, 2 down is 5. And then do the same thing. So every one step to the right is this becomes 4. And then, 5 minus 2 is 3. And luckily, we meet the k equals 4 immediately. And this would happen, if we get beautiful numbers. Then if don't, we need to use the formula and solve it. For AA student, you are expected to also be able to do this by hand. But for AI students, you will have access to calculators. So I'm going to show you on how to do this on the calculator. Okay, so first we are going to see in the calculator of here, the Ti-84 plus CE. So because this is in the form of equation, if you're not sure to rearranging, we can just use numerical solver. So first go to the math, and then we are going to go to the C numeric solver. And then the equation on the left earlier was minus 2. And on the down here, we need to write the fraction. And we are going to see it's 3 minus 7 and then x minus 2. So the k need to be changed into x. So 3 minus 7 and then x minus 2. Because we know that the position of the x coordinate earlier was on the right, so we can use a positive value. So to the right of 2 can be 3, can be 4, can be 5. Let's just use 6. And then we now press solve, and it will lead into 4. So that's our answer. The k was equals to 4. So yeah, that's how to use the GTC. But now let me show it in another calculator, which is the Ti-Nspire, if you have it here. So we're going to go into menu, and then we are going to go into algebra number 3. And then we are going to go to number 6, numeric solve. So we need to write similarly. So it was equals to minus 2. And then we need to write the equal symbol. And we need to create the fraction. Okay, so the top earlier was 3 minus 7. And then on the bottom is k. We can keep it k. And then minus 2. And of course, in this case, we need to write comma. And we are solving for k. So we need to write solving for k. And then we are going to press enter. And we get it that the k is 4. So this is the answer from the Ti-Nspire. This is the answer, how you do it on Ti-84. And yep, you are getting the same answer. All right, that's all for this video that discussing about gradients. Of course, there are, a lot more going on in the straight lines, and I will going to be seeing you on next video.